So let's take one more example on collisions. Now we have been talking about collisions in just one direction for the past 3 examples. For this one, let's take an example when we have both x and the y axis. So let's say this is the x axis and this is the y axis. So what we have here is that there is this ball which comes and strikes this another ball which is of the same mass. So if this is mass m, this is also mass m, and this ball goes in a direction that makes an angle 35 degrees with the x-axis, assuming that the first ball was actually aimed along the direction of the x-axis, and this guy here makes an angle theta. So the question is, what is this theta? What is this angle theta this ball makes with the x-axis? So v1i is the velocity of the black ball, and v1f is the final velocity of the black ball. 0 is the initial velocity of the green ball, and v2f is the final velocity of the green ball. So how to solve this? And we assume that it's an elastic collision, so energy is not lost. So whenever we have problems like these, we can always invoke two formulas, that is conservation of energy and conservation of momentum, because both of them are conserved here, and using them we can find the value of theta. So let's do that. So first of all, we know that the initial momentum of the system is v1i times m in the x direction. The final momentum of the system is going to be, now you see this vector, this is the momentum vector. Let's redraw this. We have two vectors, one in this direction and one in this direction. This makes an angle 35 degrees, this makes an angle theta. Well, as a matter of fact, from the x-axis this angle is actually 360 minus theta, right? Okay, so the final moment of this particle, we can always resolve it. We know this is m v2f, or let's make v2f smaller, and this guy here is m v1f. Okay, so this is the final moment of the green ball. Then it's going to be, if you resolve it in the Cartesian system, it should be m v2f cos 35 degrees, and which should be in the x direction. In the y direction is going to be m v2f sine 35 degrees. This whole thing can also be written as m v2f cos 35 degrees in the x hat direction, where x hat means the x direction, and m v2f sine 35 degrees in the y direction. So we can write like that. Okay, how about plus? Well, we have one more vector because of that. And if you write this, what we get? We get m v1f cos of, should be 360 minus theta, comma m v1f sine of 360 minus theta. Okay, and if you sum this up, we get m v2f cos 35 degrees plus this can be written as plus m v1f cos theta, comma the other part. The other part is going to be m v2f sine 35 degrees minus, using trigonometric relations, v1f sine 360 minus theta. Okay, so this should be same as that. Let's talk about this one. You see this is actually comma 0. There is no momentum in the y direction. So the first equation we get, let's talk about y. It gives us m v2f plus, no, this should be a sine 35 degrees minus mv1f. Looks like I made a mistake here. This should be just theta. This should be just theta. So this is sine theta, and this is going to be mv1f sine theta, and this should be equal to what? 0, because there is no y in the initial momentum, so there should be no y in the final momentum also. What does that gives us? Well, it gives us, m gets cancelled anyway, so it gives us v2f sine 35 degrees equals v1f sine theta. How about the second equation? The second equation, which is in x-axis, gives us v1. Well, again, you can cancel the m's as it was cancelled in part 1, so I'm just writing the velocities. It gives us v1i equals v2f cos 35 plus v1f cos theta. Okay, so we have how many unknowns? We do not know v2f, we do not know v1f, and we do not know theta. So we already have two equations, one from the conservation of momentum in the x direction, one from the conservation of momentum in the y direction. Where should we get the third equation from? Well, we can use conservation of energy. So we can write half mv1i squared equals half mv2, well, v1f squared plus half mv2f squared, and that gives us v1i squared equals v1f squared plus v2f squared. So now we have three equations. Okay, so what can we do? Well, let's see if we can solve equation 1, 2 and 3. So how to solve it? Well, let's see. Let's give it a thought. So what we can do is this. First of all, what we can do is, first of all, you square this. Let's square the first one. This is the tricky part. This is mostly mathematics. So what we get is v1f square sine squared theta equals v2f square sine square 35 degrees, right? Also, if you move this part onto the other side and then square it, so you get second equation, which is v1f squared cos squared theta equals v1i square minus v2f cos 35 degrees squared, right? You see, I moved it onto the other side and I squared both the sides. Okay, then you add these two. If you add these two, you will see that v1f squared comes out of the is a common in both of them. So sine squared theta plus cos squared theta gives me v1 squared equals, we know that cos squared theta and cos squared theta plus sine squared theta is 1. So these two added to give you v1 f squared, and on the left hand, on the right hand side, would we get v2 f squared sine squared 35 degrees plus v1 I squared minus v2 f cos 35 degrees squared, right? Okay, now we can use the third equation. The third equation, you see, we can write, move it to the other side, and we can write v1 I squared minus v2 f squared equals this value, because v1 f we already know. So that gives us v2 f squared sine squared 35 degrees plus v1 I minus v2 f cos 35 degrees, right? Okay, let's make an outline here. Okay, now this is a quadratic equation. We can solve it because we know v1i, we know sine square 35, we know cos, I think there should be a square here, we know this value, and the whole quadratic is actually in terms of v2f. You see, v2f is squared here and v2f is squared here. As a matter of fact, no, this is all in terms of v2f squared. So it's a quadratic in terms of v2f squared, and you can solve it. And v2f should turn out to be a positive number, because this is how the ball should bounce. So this will give us two values, probably two values, but we'll accept the positive answer. So once you have v2f, you can use other equations like here to find the value of v1f, and once you have v1f, you can also find the value of theta from here. I hope you will be able to get the right answer. Try it. You can try, let's say v1i equals 5 meters per second. With this value, try to find the value, other values.